Thank you, everyone. Thank you, Marius, for that intro. And thank you, Fresha, for welcoming us in this beautiful office. So yes, I'm Yorick Jacquin. I come from Paris, and during the day, I'm the lead developer at Wax. We're a French startup that helps brands connect with their customers on WhatsApp. And overnight, I'm the author of FastMCP, and I'm here to talk to you about how to connect AI models to your Ruby applications. So as I said, I am the author of FastMCP, but also another cool gem that you should check. I'm saying it's cool not because I created it, but because José Valim created it. He's the author, the creator of Elixir. And yeah, it's a MCP server built on FastMCP. So we can talk about it later. So let's start first with what is the Model Context Protocol, also called MCP. Well, basically, as Pavel just showed you, you have a text input, which is called a prompt. You give it to an LLM. That LLM will process that input and give you back the text output response. And for most cases, this works just fine. Let's look at that with an example. So here we have a prompt that says, write an email to Cynthia to tell her I will be late at our incoming meeting and propose to reschedule at an available time slot. The LLM processes it and gives you back a response. Hi, Cynthia, hope this email finds you well. I'm writing to let you know, yada, yada, yada. So, perfect. But what if I want that response to be more than just generating text? What if I want it to be an action? Well, for that, Pavel just showed us tools. So tools are for actions. And tools are great, but sometimes tools without the proper context, it can be a bit dangerous. Let me show you. So let's say that you just experimented with tools and you're going wild after the first few manual approvals. Now you just send the email freely, and the LLM just thought that Cynthia was a coworker of yours or whatever, a family member, and it sends the email, yo, Cynthia, what's up? But turns out, bad luck, it was actually a very important prospect. You cost your company a lot of money, and now you're fired. So that's not very cool, right? But it had no other way of doing anything else because it's not part of its training data set that Cynthia is a very important prospect. It's nothing that you have given in the prompt, in the context. But if you have actions with tools, you can have knowledge with resources. Resources, in this case, you can expose a resource that says it's an email history. And if that LLM decides to fetch that resource, it will read your emails and know that Cynthia is a very important prospect, and it will formulate the email properly and will, dear Cynthia, I'm sorry to inform you, and now you get your job. So if you like keeping your job, let's dissect a bit the anatomy of the Model Context Protocol. So it all starts with an agent that in MCP terms is called a host. That host will host one to many clients, and it will discuss with an LLM over the API. But right now, you didn't have any tools or resources. That comes from servers. Servers are a way of plugging in some tools and resources and prompts together. So think of the host as an agent, a separate host, and the servers as a plugin that you can plug into that agent through the client. But how do you connect the client and the server? Well, that's through a transport. A transport is basically the wire between the client and the server, and the transport can either be STDIO, so running in a separate process locally, or over the network with HTTP and SSE. Fine. But do you need all that for just that email example? Well, no. Let's look at this code from Ruby LLM. It's a nice gem that lets you create tools. So here we have the first tool, email history, that has a description that is exposed to an LLM that says retrieves all previous emails. It has a method which is called whenever the tool is needed. That method does gmail.getEmailHistory. It's all fictional code. But you have also another tool, sendEmail, that takes some parameters like recipient email, subject, body, and it will send the email. Then you just give the tools with the prompts, and this will work. But here, the problem is that you had to code it, right? And the real value of MCP is not in offering tools and resources. It's the connectivity of those tools and resources in a plugin way. That's why in the official docs, if you look at it, they say that MCP is the USB-C of tool calling. Why so? Because basically here, let's take back at our example. you have our host. You can connect it to different MCP servers. So let's take an example server, calendar MCP, that will show a create event tool, a remove event tool, and an events resource. There is another email MCP server that has a send email tool and an email history resource. You will connect it to the clients over stdio, and that host will manage the clients separately. So with that, let's take our email prompt. So you give the prompt that says reschedule the meeting with Cynthia to another available time today. You give the prompt with the tools and resources, so the host will send that to the LLM, and the LLM will say, okay, I see what I can do now. So let's just start with what are my events already. So the LLM will say to the host, please give me the events. The host will understand which client is connected to the proper server, and it will transfer that command to the client and the client to the server, and vice versa. And this is the return value that you see on the top right. So the LLM will see that we have an event from 3 p.m. to 4 p.m. with Cynthia at example.org. So now the LLM knows which event I'm talking about, which Cynthia I'm talking about, and its email as well. Now, what does it need to do? The LLM will process it and will say, okay, maybe let's create an event. So I will create an event from 5 p.m. to 6 p.m. with Cynthia at example.org, and I will send all these arguments to the create event tool, and the host will know that the create event tool is part of the calendar MCP server, and the client will forward the request. Then once that tool is created, it will send the email to Cynthia using the other client and the other server to say to Cynthia at example.org, apologies, I can't make it, would 5 p.m. be okay? And now you have your context that is being provided to the LLM and the actions that have been taken without your intervention or not. More about that later. So the benefits of using MCP is that with this architecture, you didn't have to write the code for the email service. You didn't have to write the code for the calendar service. And you have a very composable AI agent. If you ever need to plug in another service to move your task, to create to-dos, etc., you can plug in another already existing MCP server. You didn't even have to code it, someone from the community has coded it. Maybe in Node.js, maybe in Ruby, maybe in Python. We don't care. It will just work if you look at the code. Please don't add any server. And it can work locally through stdio or over the network through HTTP and SSE. So also, you can discover servers in some websites like Blama and look at the code yourself. But why would you choose stdio or HTTP and SSE? So this is the same code, kinda. On the left, you have the code with a tool from FastMCP that creates a task for a to-do app. And you have two arguments. One is a title, the other is a description. And in the stdio tool on the left, you will also have the call method that will actually do an API call. So if you already have your API that is available as your web app on the internet, maybe someone, a third-party user, will actually or have already built it for himself. So actually, without you knowing, maybe someone is using MCP with your API. And this is something that you can build or any third party could build. But on the right-hand side, this is something that you host. This is something that is inside your Rails app. And you can also expose the call method and create your task from your server and do anything, any behavior that you have that you want to implement to be custom for the MCP server. And then you return the new task that has been created. So with that, I have a little to-do app that I have prepared for you. So it's a live demo. Let me check out this. Yep. So you have this to-do app that is just a basic Kanban board. This Kanban board has 3 columns, one pending, one in progress, and one that is completed. It has some tasks that I have already set up. It can also be part of projects, and yep, you can drag and drop the task from one column to the other, and it works just fine. But if you want to connect it to MCP, maybe you can also install FastMCP. So let's look at how to add FastMCP. So you take your editor. Yeah, it's in white, but I'm not a psychopath. It's just for the tech talk. So yeah, you can add your gem like this, and then you will have just one command to run. It will generate some basic files, and one of those files is the FastMCP initializer. Let me close that. And this initializer, what does it do? It will mount the MCP server into your Rails app to be ready to serve MCP at this path prefix /SSE. This is just to initiate, nothing very important here. And the very important part is this one. This is where we register the tools that we want to expose to the MCP. Let's take a look at one tool, for example. So our to-do app has to expose the tasks that are already created. So this code here, it contains a description. So description is very verbose. Why? Because we're not talking to a human, we're talking to an LLM. So whenever we expose some data to the LLM, we have to be acting like we're basically speaking to a 3-year-old, because it's not good to let the AI guess. That's when it hallucinates. So here you would say retrieval task with optional filtering by status, priority, or overdue status. This tool returns a JSON object with the following fields, like total count, which is the total number of tasks, the task, which is an array of objects that will contain the properties of the tasks, and filtered by status, filtered by priority, and filtered overdue, which says, oh, okay, which filter have I applied for this request. Then another interesting part here is the arguments. The arguments is actually, maybe you've already used this syntax. This comes from dry schema, which is a dry gem. And thanks a lot to dry gem for this work. It's awesome. What I've done with FastMCP is that you can write your tool arguments like this with their syntax. And actually, let's look at the first one. It's an optional field, but when it's here, it has to be filled and it's a string. It has to be included in the synum, which is the available statuses of a task. And the description is filtered by status, pending, in progress, or completed. So this is the description that is given to the LLM to understand how to use these optional arguments. Same goes for priority. It's an integer. It can be composed, it can be included in 1 to 5. For overdue, it's a Boolean. And for limit, it's an integer that has to be greater than 0. And all these arguments that you see here, they have to be present in the call arguments. So they are mapped from the arguments to the call arguments. And here this code is doing something very basic, like let's take all tasks, apply the filters if needed, apply the limit, order by due date, and let's return the result as JSON at the end. And the magic with this is that actually it doesn't only transfer that to FastMCP valid payload, but it also does the validation without you needing to write the code. So if I call the status and I include an invalid status, it will raise. That's what FastMCP does. So let's take a look in the MCP inspector. So the inspector, if you're starting to do some MCP servers, it's going to be your best friend. It's what helps the LLM to, actually helps the developer to understand how the LLM will use your server and how to debug your tools. So let's try to connect. So this, on the bottom left, it's the history. So it's what the client does to your server. So it's basically a makeshift client that you can use. In resources, I don't have any coded. That's something I will explain later. And in the tools, I can list the tools. So this is the tools that are exposed. And if I look at the tools, I have my get all task tool here. So this is the one I just showed you. If I take a look at what the tool/list command that the client has sent us, let's take a look at the response. And if I get at my get all task tool here, you see an input schema. So this is what the LLM will see. It will see that it takes a status with an enum. This is what we have declared in Rails. It has a priority that is also an enum that can be 1, 2, 3, 4, 5, etc., etc. And here, if I want to provide an invalid status, let's try with OK. And I run the tool. well, it will return an error. Status must be one of pending, in progress, completed, and this is all with FastMCP code. If I say pending, it will work, and it will only return the tasks that are pending. And that's how you use the tools. So now, also, if I want to give you a bit of live demos so that you can understand the power of MCP, I have prepared something cool. So Goose is an MCP client. It's an open source MCP client coded in Rust. And let's try to add our server. So you go to the advanced settings. These are often called extensions nowadays, so that it's more user-friendly than saying MCP server. And I have already two extensions that are configured. One is the Tavily web search, which lets the LLM do some web searches on a query. And one is the browser MCP. This is for a little fancy trick that I will show later. It lets you control your Chrome instance from the LLM. So let's add our server. So it runs not over stdio, it runs over server sent events, SSE. And we'll call it to do. And the endpoint is coding with one hand. Hola. Thank you. I messed up 0. Thank you. Nice, thank you. So nice, now it's connected. So what I can do is to give it a prompt. So I'm a Frenchman, I want to build something big. Let's build an Eiffel Tower. So let's try to do that together. So I have a little snippet that I have prepared. So please gather some information about how to build an Eiffel Tower. Then do the following: create a project for it without any tasks. Then create at most 5 tasks. Move the first task to in progress. Once done, navigate to a website and then navigate to another. So what has it done? It has already called the web search to gather some information. So here it called the query tool with how to build Eiffel Tower. The output is everything that it found on the internet. And that is a concern that I will expand later on. So here it has also created my projects in the background, so we'll show it next to it. So it has also created a project here. Here it's creating tasks live as we're talking, so you can see the task appearing right here. With first design and engineer specifications, it's found that it's a high priority and it expects that to be done by July 15th, so we have some time. And then 1st of August, we should have the foundation construction and site preparation. And now it's moving through the other task, and I asked it to move the first task to in progress because I'm someone very proactive. Oh, it also it also switched to okay, and it switched to the end to my end slide. So things to consider with MCP with this small demo is that writing MCP tools is not like writing a REST API request because MCP tools are more like writing a full-fledged action, like a bit like a user feature that has a start and an ending. So it's not behaving well when you have exposed too much tools. When you say, okay, you have a project, you have a task, you have a subtask, no, it wants everything. But not too much, because every tool comes with a space that it's taken in the context window, and you have to optimize that context window, because even though we're talking now 1 million, 5 million tokens, what we see is that the less tokens that we use, the more the MCP server behaves, MCP client, I mean the LLM behaves. So that's why with MCP tools, less is more. And your MCP documentation needs to be very explicit, as I talked about, because you don't want the LLM to hallucinate. And you should also optimize your tools so that they are the most cost efficient. I told you that each tool will be some tokens that will be added, and each token has a price. So every time the MCP the LLM has to do some tiny MCP calls to achieve a task, this will cost a lot, and it's something that your user might be angry about. And also MCP is still new, pretty new, and subject to change. It already has 2 revisions. It has another one that is in draft. And it's something that you have to watch out for, because Whenever you're trying to implement a new MCP server now, it may be already something that has been deprecated because it's using a deprecated transport like SSE. And different clients have different implementations because the protocol specification is so vast and so permissive that anyone can interpret what the resource is and how to use it. That's what we see with different hosts like Cloud Desktop or Cloud Cursor. And yeah, HTTP SSE can be messy and it's a hell to host because you have to maintain some long-lived connections. So now there is streamable HTTP, which will help with that. And that's why you can use stdio to SSE proxies when needed. So this is something that actually works great from what I have tested, and I encourage you to try that if SSE doesn't work out for you. Yeah, and also for the conclusion perspective, in regards to MCP, not all LLMs are born equal. MCP has been created from Anthropic, and it has actually trained its LLM in a big data set that helps it understand how tool calling and how MCP works. So that's why the Anthropic models were the best for a long time, and in my regard, they're still the best. It's because it's part of their DNA to understand what MCP is. And that's why also it's not just hype, it's here to stay. It's because it's a real feature. It's not a gimmick. It's something that the AI providers are building into their LLMs now. And it's a great opportunity to open your app to many use cases because if your user used to use your app on their own and they are struggling to find their way, an LLM might maybe without a UI do better than a user. And it also brings a whole new aspect to app security. And that could be a whole other talk, but prompt injection, tool poisoning, and token theft are a real thing. So I would suggest you to look into that before trying to release MCP servers in the wild. So in some sense, with great power comes great responsibility. And that's it for me. Oh, thank you to Ruby Europe, Pavel and Marius. Thanks a lot for inviting me here. And Wax for also participating in me being here. This is the QR code of FastMCP if you want to go try it out. And I will make this talk open source with the to-do app as well if you want to see how the server works, just tonight. That's it. Thank you.
Thank you. Are you ready for the question?
Yes, of course.
Anyone? Any questions?
Hello.
Hello. So on one of your slides, there were two approaches using SDIO and yeah, this is one.
Yes.
So I noticed that you inherit from different classes. So there must be a difference. And also these tools, they are callables that I can see. So they implement the main method call. So are they any different from any other callable that I would create, say, using prop or another class? This register tool on the left side of the row, does it require a specific class to work?
Well, this is a FastMCP code. So on the, thank you for your question. On the left, you have a server. You see line 2, I initiate a FastMCP server. And that server comes with some capabilities. Something that I didn't mention is that for the HTTP side, it's mounted as a rack middleware. But for the stdio side, I don't need rack. Actually, it's just some plain old Ruby code. And this FastMCP tool class that you talked about, this is a super class that comes from FastMCP, and this is the one that implements the call method. So actually, it doesn't implement it, it expects you to implement it because it will call a method that will call your call method, and that's how the framework kind of works. So whenever the LLM will try to request the tool that you register with the server that register tool, then it will know which method to call, the call method, and it will do the validation beforehand thanks to the arguments that you have defined. I don't know if it answers your question.
Yeah.
Okay.
Sure. Question number two. You mentioned the proxy for STDIO to HTTP. Is there an existing proxy that works well for MCP?
Yes, so part of the job for Tidewave, the other gem that I worked on with José Valim, his team created an MCP proxy coded in Rust that works very well. And actually, it's also funny because that proxy takes in the role of kind of an aggregator of how the clients behave, because as I told you, you have so many clients handle differently reconnections to your server, and especially with SSE. So that proxy will try to guess how your client works and adapt to the server so that it fires the proper request and doesn't mess up with keep alive loops, etc., etc. But yeah, the one that Tidewave has is working great. Yeah, it's coding in Rust. But also, I think Cloudflare has released one, an official STDIO to SSE. I don't know I forgot the term. Proxy, sorry. Yeah. You're welcome. Thank you for your questions. Any other question?
Anyone?
Yes, we have one in front.
This is probably more of a implementation detail, but authentication. Obviously, we're talking to different services. I know there's been some back and forth with, I know with Zoe, and there's been some back and forth, and they've been really quite responsive to some of the feedback and the community. But yeah, how does this library handle things like auth and making sure you pass right tokens around and stuff like that to get the right details?
It doesn't. So basically, at the beginning, before the new revision, I just implemented a very naive authentication with a standard API key. It was more meant to be used by companies internally so that they could process the MCP for internal purposes. Now, with OAuth, actually, it becomes something that can be implemented for any production-ready app. So if I just show you part of the code, yes, I will show you just a part of the documentation about tools to illustrate what I mean. So yes, we have the request headers that are accessible from within the tools. Is it here? Oops. Oops, no. Whoa, what have I done? I have never done this in my life. Okay. I can do it. Yeah. So if I have access to my request header, I can do some logic around that to say, okay, for this tool, I can try to check this header, and from this header validate that my user has some access, or etc. So it works well with bearer tokens, but not with OAuth. But it's something that I'm working on, and with streamable HTTP as well. And any contribution are welcome, of course. But yes, it's something that's coming, but right now we can do it like this.
Thank you.
Thank you.
Thank you very much.
Thank you, everyone.